All right, let's get started. Hi, everyone. Hello, hello, welcome. Welcome to the AI user group. Who is here for the first time? Okay, hi, nice meeting you. I'm Cyril. I'm gonna be your host. We are organizing events for professionals every week. So it's always at this venue. So if you're interested in AI for marketing, AI for design, AI for engineering, we are hosting meetups every week. And then we are also hosting this conference. So it's gonna be on April 15. And it's a 3-day event, and it's following the same pattern. So first day is for marketers, second day for designers, and third day for developers. So we have free tickets, so you can scan this QR code. We are hoping to be 1,000 people. So let's join so we reach this goal. This is for like free tickets, so it's gonna give you access to main stage, booth, and networking at the end of the day. Then if you're interested in workshops, we are offering 50% discount, so it's $49 a day. And it's giving you access to 3 tracks of workshops. So yeah, if you want to be hands-on, that's the plan for you. And it's gonna be this QR code if you want to scan it. Cool, so agenda for the day. We're gonna start with Harry, right here. He's ready, with embedding models from top down. Then Joël will talk about build a fully autonomous AI agent with a brain network. And then Anthony will talk about AI-powered conversations. Then we have a habit here, it's to organize an open mic. So you come here if you have anything to announce. It can be work-related, like if you are looking for a co-founder, if you are hiring, if you are looking for a job. So we are a community, we try to help each other. Also, if you are launching something, it's a good medium for you to get like your first users. So think about it, and at the end of the event, you can join me on stage and present what you want to share. And after that, we'll start networking, so it will be in the back, and we'll have pizza to network, and our doors close at 8:50, just as a reminder, because it's important. All right, so let's get started with Harry, our first presenter. We can give him a round of applause. Okay, let's do this.
All right, okay, awesome. I can hear myself really loudly now. So hey guys, my name is Harry Patchigolla. I work as a data scientist for Autodesk. And today I want to be covering how embedding models work from more of an intuitive theoretical lens. All right, before I get started, one thing I want to mention is that as developers, it's really easy to use these models as black box tools. Right, you have a chunk of text, you send it to some embeddings endpoint, and you get a sequence of numbers called the embedding. You're able to store them in, say, a vector database, and it just so happens to be that similar chunks of text have similar embeddings as defined by some distance metric. And to be honest, for most of you to deliver value to your respective customers, it's not super necessary to be able to explain how exactly these embeddings are being created. But I come from the perspective that in knowing so, you get a better appreciation for not only the model, but the code that your end users are interacting with. So the way I plan to break this down is by answering 4 overall questions. All right, we'll first talk about what it actually means for a sequence of numbers to represent something. Then we'll go into talking about the dimensionality of embeddings, right? Why are embedding dimensions so high? And why can't we just increase the embedding dimension? One thing I want to preface with is that there are pretty simple answers that you can probably think of for these questions. But once again, my objective is to give you an intuitive reason, focusing more on the theory as to why the answers exist the way they do. And then towards the end, we're just going to talk about other types of embeddings. So jumping right into this, let's talk about text embeddings, right? Which has a very simple definition, which at a high level is a numeric representation of a piece of text. And this has existed for a while, well before the whole AI boom, if you think of something like ASCII, right? Take, for example, the phrase, "Hey there," with that exclamation. You're able to represent this in some kind of numeric manner. And the reason being is because our computers don't necessarily understand the letter H, but they understand, quote unquote, the letter 72, okay? But there is obviously a clear problem here, and it's that this representation of "hey there" doesn't really take into account how you use the phrase in day-to-day life, right? For example, you wouldn't say "hey there" at a funeral, but you'd most likely say it when you're meeting someone for the first time. So to dive deeper into what I mean by representing something as numbers, let's take a step back and focus on a fundamental principle within deep learning. So over here, I have an image of a relatively simple model. It has as an input 10 nodes, and as an output 10 nodes as well, with 3 hidden layers. Now, I want to have you guys make an assumption about this model. Assume it's really good at the task you have it being trained on, right? So assume it's a model that's really good at taking an input and classifying it as one of 10 different outputs. Or maybe in a general sense, assume it's really good at taking a sequence of max length 10 and outputting the next token or the next word. In this case, your vocabulary size might just be 10 words, right? No matter what assumption you make, if this model is really good at the task at hand, then that means as values propagate throughout the network, those values are not random values, right? Take, for example, the values that are being propagated in this 3rd hidden layer. Clearly, those values mean something about the input because the output layer is able to give a very accurate prediction, right? So you can think of an embedding in general as some output of an intermediary layer within your overall network, because those outputs or those values represent the input in a pretty accurate way because the model is working pretty well. Now, in most language tasks, a simple neural network like an ANN doesn't really suffice, which is why I want to change gears into talking about attention. Okay? So this paper by Google, you probably have heard of it, it's called "Attention is All You Need," was released back in 2017. And the core operation within attention is the scaled dot product attention. Right? Just to read it out loud, it allows you to dynamically weigh the importance of different tokens in the input sequence when encoding each token's representation. And I want to break down that equation on the right-hand side here, right? Where you can see that attention is a function of 3 parameters, the query, key, and value matrices. This is my kind of horrible job in trying to depict what's going on, but one thing I want to make sure that you understand here before I dive deeper is what's the input and output of attention. The input is some embedding representation of the text, which we'll talk about soon, but the output is refined embeddings of that same text. All right? And that's the main thing I want you to understand here, even if you're not necessarily able to follow the intermediary steps. So to dive deeper, the main thing I want to explain here is if you have a model like an LLM that's really good at predicting the next word, the first thing you have to give it as an input is some sequence of text. In this case, my orange cat bit me on my blank. It could be bit me on my arm, bit me on my left hand, but whatever it is, the model is really good at predicting that next word. In fact, when it comes to training an LLM, which is outside of the scope of what I want to talk about, when you train an LLM, you first focus on having it predict the next word before it's a question and answer system. So the very first step is you need some numeric representation of these individual words. And that comes from something called the embedding matrix, which is a learned matrix. These are the weights of the models. And initially, you just pull the embedding from the embedding matrix. The embedding matrix has dimensions of the vocabulary size and the dimension itself. So say that your vocabulary size is 50,000 words in the English dictionary, for example, then you just pull that embedding where each row represents one individual word. Now, initially, when you train an LLM, these will just be randomly initialized, but as you go through that training phase, those values will have more meaning. But what you want specifically is an embedding for this input text. And the way that happens is through the query, key, and value matrices, all right? These weights, which once again are trained, re-represent your embeddings in a way that allows the model to understand which words are important for other words. In this case, the word orange is saying something about the word cat. It's not really saying something about the word me. On the other hand, the word bit is saying something about the word cat and the word me. And that's what the query and key are trying to do. In general, the query represents what that word is looking for, and the key represents what that word can offer. In this case, the word orange can offer something to the word cat, whereas the word on or me doesn't really represent much or offer anything to the word on. And when I say offer, I'm talking about quantifying that attention value, which is what this attention map comes into. Overall, after some more weird math that goes on, you have these refined token embeddings, which once again, previously these were independent embeddings. The refined ones take into consideration the context of the other words around it to have a better and richer representation of the input text. There was a GitHub repo I found that I think does a really good job in helping you visualize what's happening behind the scenes. I have it linked at the last slide. Over here, you see that the input are vector embeddings, which is coming from the embedding matrix, right? Each row represents an embedding for a specific word. And then you convert this into a query key and value vector, which through this whole self-attention mechanism has some output. Now, through this output, you do some more math, and it's able to very accurately predict the next word, in this case, left. So what exactly is happening here, right? You have a model that's really good at predicting the next word, and through the intermediary values, these embeddings get transformed into a value that makes the output layer predict the accurate next word, which means that these intermediary values can be thought of as the embedding for the input text. Okay? So these values, like I said in the previous slide, are not random. They encode something about the input that allows the model to make its next prediction. So the embedding for these LLMs or these vectors can be thought of as just some output of an intermediary layer. And it tends to be that final layer. So for a lot of LLMs, in this case, say like llama embeddings or sentence BERT embeddings, it's just some concatenation, say average pooling, across all of those embeddings in that final layer. Okay? And the reason why this makes sense at a high level is because the model is really good at what it's doing. As a result, the intermediary values encode some meaning of the input, and the overall purpose of embeddings is to represent the input, in this case, text. So we just talked about why embeddings kind of function the way they do, but you've probably noticed that embeddings, I don't know why my AirPods are connected, you probably noticed that embeddings live in very high dimensional fields, right? In the previous GitHub repo, you saw that embeddings were 700 plus dimensions. A lot of embeddings in general, say OpenAI embeddings, are thousands of dimensions. So why does it make sense to have so many dimensions? Now, there is a pretty simple answer, and this comes down to one of the fundamental principles in deep learning, which is the model's capacity or expressive ability. Given a specific task, you want to make sure your model is complex enough to be able to capture the distribution of that task. All right? The human language is pretty complicated. As a result, you want a complicated model to address it. And this equation over here just formalizes it, where your model has specific parameters called data, and you want to find the optimal values of those parameters such that the expected loss of your model is going to be as small as possible. That's essentially what that equation is saying, and hopefully that's not too hard to wrap your head around. But I want to dive a little bit deeper and introduce two topics that are seemingly different, but I'll tie it together towards the end. The first thing is, what does the embedding matrix really represent? Like I said, each row represents the embedding of a specific word in your vocabulary. And there's this common connotation that I've read in different articles and videos that says that each individual column represents some human interpretable concept, right? You might have a column, say column 42, that represents gender, or you have another column that represents emotion. Now, that's not exactly true, and the reason being is that these concepts are represented as directions, not as dimensions. So semantic properties like gender and emotion are typically encoded across many different dimensions, but they're not attributed to one specific column or dimension in your embedding matrix. I have an example of that in the bottom right, where a pretty typical example is saying oh, you have the vector for king, and you subtract from it the vector for queen. Or you have the vector for woman, and you subtract from it the vector for man. And those resulting vectors point in a direction that encodes the meaning for gender. Okay? But the main thing here to notice is that it's a direction, it's not a dimension. And that's a pretty common misconception that'll help you understand some later concepts here. The other thing I want to talk about is, what do I mean by the expressive power of an n-dimensional field? What even is an n-dimensional field? So to break this down, geometrically, n dimensions refers to how many vectors that can be placed in n dimensions, such that the angle between any two of these vectors is 90 degrees. So for example, in 3 dimensions, you can only have 3 vectors, such that the angle between any 3 of these is 90 degrees. And the reason why this is important, because orthogonal vectors, which is vectors that are 90 degrees apart, are linearly independent, which means that depending on how many orthogonal vectors you have in your dimensional field, you're able to represent seemingly different or distinct ideas. So say in the case of 2 dimensions, where there's only 2 orthogonal vectors, you can't have more than 2 independent directions, so unrelated words or concepts would have to have some overlap in 2 dimensions. But this is not actually true for higher dimensions, and that's what the graph on the right-hand side shows. What I did here to create this graph is I generated 1,000 random vectors in different dimensions, and I show a distribution of the different angles between all of these vectors in said dimension. What you'll notice here is that in 2 dimensions, there's a uniform distribution, meaning that most of the angles aren't really like populated in one specific area of the dimensional field. Whereas in higher dimensions, say 100 or 1,000 dimensions, you'll notice a really stark peak between 90 degrees, right? In general, in higher dimensions, many vectors are nearly orthogonal. And that's really important because as you have more orthogonal vectors, you're able to represent different ideas with little overlap. The human language has many different ideas, say king, or say royalty, human emotion, fruits. And if you want to represent these different ideas, you want to point them in different directions. In 2 dimensions, there's not that many directions to point to that are different from each other. There's only 2 really. But in higher dimensions, as I just showed, there are many different directions that don't overlap with each other that allows you to capture the differences in the human language. So with that said, why don't we just keep increasing the dimension size, right? I've just shown that you have more orthogonality in higher dimensions so you can represent different concepts more, so why don't we just keep going? So the simple answer here is just due to some limitations with memory and computation, right? When you have a very high dimension, in this case, your embedding matrix is V by D. By increasing D, you're gonna do more like computation with the query, key, and value matrices. You're gonna just have to store all of these values, and these LLMs are pretty big to begin with. But even if that wasn't an issue, right, even if we had infinite resources, it still doesn't make sense to increase the value of the dimensions. The first concept to help understand this is the idea of overfitting, which is pretty common for most models, right? Like I said, you want to have the model have enough expressive capability of underlying your data's distribution. However, it tends to be that if you have too much expressive capability, you'll pick up on noise and nuances within your data that isn't true for overall data, that isn't true for like customer data, for example, the data that your customers use to like predict from your model. So while that is a good concept to help answer this question, let's just dive a little bit more into some intuitive like math behind it. And so there's 2 concepts I want to talk about here. The first one is rank. Rank is really important in linear algebra. Essentially what it states is that it is the number of linearly independent rows or columns within a matrix. Over here I have an example matrix, matrix A, and we say that column 3, for example, is linearly dependent if it can be reconstructed as a linear combination of other columns. So if column 3 is equal to 2 times column 1 plus 3 times column 2, and then you get column 3, that means column 3 is dependent. Essentially why that's important is because column 3 isn't really adding anything to our matrix, right? If you can just reconstruct it with a linear combination of other columns, column 3 doesn't mean anything for our matrix. So what does it mean when we apply this idea of rank to our embedding matrix, right? Linearly independent rows mean words can be represented uniquely. That's what the objective is. But remember, I said that columns can't really be thought of as specific concepts. They're just general features within your embedding matrix. But it kind of turns out that when you focus on your language data, right, your training corpus of data is going to be limited. There's only a finite number of concepts, a finite number of like English meaning within your training data. And that's what I'm going to refer to in my next topic as the intrinsic dimensionality. Like most things in the AI space, it's an overly complicated name for a simple concept, right? So intrinsic dimensionality, R, of a corpus of text represents the minimum number of independent dimensions needed to capture the meaningful structure and relationships within language data, right? So to kind of put a better example on this, say that you train an LLM only on the text of Harry Potter, nothing else, so only on Harry Potter text. The word evil in Harry Potter has a specific connotation with it, right? It's gonna have this mystical, more gruesome connotation. On the other hand, the word evil has a different connotation when we talk about Winnie the Pooh, right? It has a more comical connotation, a more jovial one. But my point here is within the concept of Harry Potter, there's only X or R number of dimensions that you need to truly represent the text and the meaning behind the language of Harry Potter. And that's what I call R. When you increase D of your, the dimensionality of your embeddings past this value R, every extra dimension is just gonna pick up on noise or some redundant information that isn't really useful for the model to represent its training data. And just to prove that I'm not making this up, there was a study that was published last month actually, showing that it is a pretty active area of research called measuring intrinsic dimensions of token embeddings, where they have two common ideas, the intrinsic dimension and the extrinsic dimension. And essentially what they've shown is that even though embedding matrices live in very high spaces, the amount or the effective dimensionality, which is what ID is taking care of, is much lower. Right? So the amount of dimensions needed to describe the structure of your embeddings is actually much lower than what you would expect or what the actual dimensionality of your embeddings are. Essentially, the main conclusion you can draw from everything I said here is that your data has finite amount of concepts, hence it has a finite number of dimensions that can represent it. Even though it's hard to identify what that finite number is, in theory, if you go past that, you're just gonna pick up on noise and redundancy. So to put everything back together, I just talked a lot about text embeddings. I'm not really gonna touch image embeddings, but still the same overall concept. But there is just one key thing I wanna say that I wasn't exactly correct on before. I said that an embedding can represent text in a sequence of numbers, but it's not just limited to text or images, right? An embedding is just a numerical representation of anything, and I quite literally mean anything. You can have embeddings for chairs, you can have embeddings for different types of raisins, you can have embeddings for types of glasses. Right? The reason why I say this is coming back to my original point. For as long as you have a model that's really good at a specific task, any of the intermediary values to an extent encode that input. And as a result, those intermediary values can be thought of as an embedding. When we looked at the transformer with the attention, those intermediary embeddings and pooling them together was the final embedding that you get when you make an embedding request. In general, say that you have a model that takes an image of a plant and accurately classifies it to being one of 10 different species of plant, then the output of, say, the third layer is a valid embedding for that image of a plant. So you can do RAG on plants by just looking at the output of some intermediary layer. So I talked about a lot in the past few minutes, but I didn't touch upon several concepts, which is tokenizing, positional encoding, and a lot more. But the resources here on the right not only help me make these slides, but I think they dive a lot more deeper into some of these concepts. So that's all I have for you guys today. If you have any questions, I'm gladly to take them.
Yes. Congrats.
Awesome.
Do we have questions for Harry? Yes?
Oh, okay. Sorry.
No worries, no worries.
I really like the presentation. I think you covered the mathematical side really well for someone who does not have a huge background in mathematics. I'm curious about the text embeddings because you kind of dove into text embeddings for just letters. How much research is placed into image embeddings or let's say we're dealing with plants or dealing with objects? When you're thinking about creating these values, not just for text, how are you dealing, what does the research look for that? How much time does that take? I'm just really curious.
Yeah, so over here I showed this as just representing a deep learning model, but every specific task has more specialized models. So say for images, you have convolutional neural networks. For language, you have transformers and attention. So that's kind of where the research is going. How do you represent this different kind of data? What embeddings really are is kind of just an output of being able to train a model that does this, right? So an output of being able to train a model that can predict the next word is, say, you're able to represent the input, because the network essentially has to represent the input to create that output. And so that's what an embedding really is. So I'm not sure if I'm exactly answering your question, but the research right now is how do we create more specialized models for specific tasks? And in the embedding, you can kind of think of as some +1 that comes out of that research.
Yeah, got it. Yeah. most of the processing or like the research is done on like developing the layers and training the model.
Correct. I mean, there's a whole area of literature that I didn't even talk about, like how you actually train the model, how you come up with a good architecture. Just embedding is a very small, like, I mean, it's really big in the LLM space, but it's a really small concept when it comes to the overall literature out there.
Okay, all right, thank you.
Yes, of course.
More questions? Harry, I have one. Can you explain why orthogonality is important for embeddings?
Yeah, that was a kind of a difficult concept to explain. Essentially, what I'm trying to get at is there's a lot of different ideas in human language, right? And orthogonal vectors point in different directions, right? So if you want to encompass different ideas in lower dimensions, there's not too many opposite directions in lower dimensions, right? Or there's not too many independent directions. So in higher dimensions with more orthogonality, you can represent concepts that are very different with very little overlap. In case like that didn't make sense, I'm sure you might have seen like you take OpenAI embeddings and you do some dimensionality reduction until you can visualize them in 3D or 2D. And you notice that when you do that, a lot of the points make sense, but some of them don't really make sense, right? And the reason being is because in 2 dimensions, it's hard to encompass meaning, whereas in higher dimensions, it is much easier to. And one of the many reasons why is because of this idea of orthogonality.
Cool.
Awesome.
More questions? Yeah?
Hey, great talk. I wonder if there's a way, a question for you, is there a way to calculate the intrinsic dimensionality, or is it just experimentation? And also related, I'm curious, do different languages have different dimensions, like numbers in terms of ID?
Yeah, I mean, so I can't speak like, I can't give you an exact answer. I'm still like not too knowledgeable on this field as that question would require me to be. But in general, yes, you can like empirically try to figure out the dimensionality of your data. There are a few R libraries that actually try to do that. In fact, the study that I showed here, give me a second. The study here actually proposes a method to do that and applies it to LoRa, which is a way of fine-tuning an LLM. That's the whole connection between rank and intrinsic dimensionality there, if you're curious. But to answer your second question on like different languages, yeah, like you can't just use like the embeddings of like it really depends on your training data. That's what I mean, right? The embeddings of the word like hello in English and the word hola in like Spanish is going to be different, right? And that's just because the Spanish language is constructed a lot differently than the English language. So you will need different embeddings for that, if that answers what you were trying to say. Oh, never mind, I did not answer what you were asking.
Sorry, I was more wondering if like the number of dimensions is different across languages, because then that means the number of concepts in different languages are different.
Mm-hmm. So the reason why, like the answers to that is yes or no, it really depends on your training data. Remember when I was like, oh, if your training data is only Harry Potter, then yeah, you probably need smaller dimensions. If it is just like a much larger corpus of text, like kind of like what OpenAI did, literally everything on the internet, then yeah, your intrinsic dimensionality is gonna be significantly larger, but it kind of turns out that you don't really need all of those dimensions to do a good representation of your language, and that's what this paper goes into. So yeah, with more languages, you might need more dimensions, you might not, depends on your training data.
Gotcha. I'll ask you more questions after.
Sounds good, sounds good.
Thank you.
Well, more questions? Yes? Yeah.
Thank you. Hi, I'm Philippe.
Hey.
I have a question on these embeddings, and I've been playing with vector databases and trying to do RAG and all that good stuff, and there seems to be that embedding step for your data to put it into the vector database. But one of the things I'm challenged by is like I want to use different LLMs, but do I ultimately have to choose the embedding that the LM depends on, and are they different? Can I find a way to use different LMs with just one vector database and one set of embeddings? It's like I'm trying to find a creative way where I'm not locked in, where I have to do another embedding, you know, and put in the vector database for another LM, and it gets more complex.
So if I'm understanding your question, you're pretty much saying like, obviously you get a bunch of embeddings from different LLMs. You're asking, are you just limited to that LLM in particular?
Yeah, I mean, can I put basically one set of data in and have all LLMs be able to use and find that data in the vector database? Or because they use different embeddings, I'm stuck having to repeat the process and make the database way bigger and not
So you're saying like,
compatible.
can you just put in a bunch of OpenAI and like
Yeah,
Anthropic and like Llama embeddings
Yeah.
together? So in reality, not really, because one, the dimension sizes are different. Certain OpenAI embeddings are like 1,000 plus. I think Gemini embeddings are less than 1,000. So you can't really do that distance calculation when the dimensions are different. But suppose they were the same, right? I mean, there are studies that show that like, even though the values of these embeddings are different, within their respective embedding spaces, they represent similar things. But it's not necessarily true that Gemini embeddings for hello is the same as OpenAI embeddings for hello. Because once again, it's a different training data set. It's a completely different architecture. They're closed source models, so it's hard to really speak about that. But because they're very different in terms of how they were trained and how the model is designed, you can't just take those two different types of embeddings and assume that like you can just have close text by that. So you would have to like partition your vector database,
Okay,
have one.
so if I want to do RAG, I kind of have to choose the LLM
Correct.
that I'll be doing RAG with.
Yeah, and there's actually a lot of interesting articles on how to go about choosing the right embedding model, because certain models are better at embedding certain things than others, right? Because some models are really good at embedding code, others are really good at embedding like artistic like languages, things like that. So I would definitely urge you to like do research on what kind of model is best suited for the type of text you're trying to embed, and then go from there.
Awesome, thanks.
Cool. No more questions? Great. Thanks so much, Harry.
Thank you, guys.
Great talk. Next, it's going to be Joël.
Nice. Okay. Hi.
Do you need some?
I think that's good.
You're good?
Yeah. Okay. Hi everyone. So I'm Joël, CEO and co-founder of Humiris AI. So we're gonna talk about something very interesting for me. Is the future of AI models. I think 2 years ago we saw GPT for GPT 2.5. And just maybe 2 weeks or 1 month ago, we saw GPT 4.5, and we saw like GPT 4.5. There's some deception, you know. And so some people say like pre-trained model, pre-trained system is dead, and now is everything about the post-training. And something we believe in Humiris since 2 years now is like to scale every model, we need to find a way to make it on inference. You cannot every time just buy GPUs and create a bigger model. Like, it cannot work. It's good because 2025 is the year of post-training. If you don't do post-training, it's just hard for you. And 2025 is the year you can compete with OpenAI. Like some people say, no, just build agents, don't compete with model, that's good. But there are lots of agents who is built, and each year there's another new agent who is powerful because there's some new model, and the other agent just are forgotten. So today we're gonna talk about how you can use brain network, how you can mix different model, create your own post-training model, and to build a powerful model. Just to show you an example about one of our model, we call Daddy One, who surpassed Claude 2.7 in coding with this method. Just a video about how he's doing. So you can see here, like he generated a lot of code, more than Claude. And I asked him to make me a snake game. So it's simple question, but it's a lot of logic behind. and Claude 3.7 generates, but it was not so good. And our model just generates in one time and very good. And Claude 3.7, before have the good answer, I need to prompt him 4th time. So how we do that is what I'm gonna present to you today. Yeah. So when you talk about the GenAI stack, there are a lot of things. I think you know very well every company here this type of level. You have the compute, the cloud platform, and you have foundation model. And so there's something we call. This one is better. Oh. Okay, so after the foundation model, you learn about fine-tune model. If you want to build vertical model, it's good to fine-tune. There are some people who already fine-tune model here. Okay, that's good, because it's very hard to fine-tune. It's not something you just wake up morning and you do it. It's why a lot of people do RAG. Maybe there's people who do RAG here. So RAG is more easier, but fine-tune is something very hard, and you don't need it. Like, if you prompt very well, your model is good. But in some specific domain, you need to fine-tune, or you need to do a lot of post-running, how to say, sequence, to make the model better. And after you have MLOps, data platform management, and now you have agents. So we at Humiris, like what we're gonna talk today is more like the post-training models. So in the post-training model, you can have fine-tuning model, vertical models. Vertical models is very good. It's something, if you are building agents, you need to have your vertical AI models. When you take company like Cursor, Perplexity, every agent builder, you can build the same thing like them, but they use the same model like you. But the model you are using, the application is not the same, because they add a lot of things. They make a lot of fine-tuning vertical. They made a lot of things behind that. So in the post-training, you have fine-tuning model, vertical models, and reasoning models. And here we're gonna talk about how you do that together. So when you want to create agent, it's very easy. Agent is model, orchestration, and tools. Like, it's not something very complicated. And something I like to talk about is human agent and dog agent. So why human agent and dog agent? There are lots of people I don't know, on LinkedIn I saw, our agent now is 95% of coding and just 5% of AI. Like, if you believe on that, I'm sure in 2 years you'll be dead. Like, don't do that. Don't build dog agents. There are a lot of dog agents, and we don't need it. We need human agent. So how human agent is different than dog agent? I said something the last time. I'm like, you can take 1,000 dogs. They will never be smart like one human. So now there are a lot of things about mischief agent, multi-agent orchestration. That's good, but in some cases it's good to have dog. I don't say it's not good to have dog agent. I think if I want to do a customer service, I don't need a good reasoning model. I just need people who do their tasks very well. And after the agent go to sleep. So it's just the only thing I want. But if I want something in fintech, in health tech, in coding is specific domain we work. We work with big Fortune 500, big companies, and this specific vertical. You need a specific brand. So the difference between dog AI and human AI is the brand. And so, like, when you take the same thing, like about the agent, you have tools, orchestration stuff, but only the brand is important. So how you could build this brand? So when you use GPT-4o, of course, it's the dog AI brand. But when you use like the mixture of different model or reasoning model, is more like you use human brand. So what we did here, you just have one model here, and here you have mix of different models, GPT-4o, Llama, and everyone. But something is hard is put people together, that's good. I think here, we come here very different, but make people work together to give something very good is a big problem of our humanity. I think the progression of human. Now we go to space. We will go to Jupiter. I don't want to say Mars. We will go to Jupiter one day because we know how to communicate together. We know how to work together. And work together is something for us is very important because it's something who can make LLM better, agent better. And one of our model, like I said, is really be the result on the benchmark. So Emmy, who is one of the best mathematics benchmark. So our model surpass O3, O1, and DeepSeek with the mixture of AI technique. And yeah, so how to build this human AI agent? I talked before about the different model. So you have predictive models is very important, like machine learning models. But for me, fine-tuned model is a little bit predictive, because when you fine-tune model, most of the time he will give you the answer for that you fine-tune. So they will be very vertical, very very custom for what you need. And so when you mix this fine-tune model with very good and task is deterministic because in beginning of GenAI you have GenAI, generative is very generative. It's not so deterministic, and now we're going to more deterministic solution or answers. And for that, when you fine-tune multiple model in multiple cases, he will be better than if you just use one big model. So you fine-tune different model and you mix-tune together. So GenAI, for example, like I say, is good for automation, rapid prototyping, personalization, but there's a big problem with the black box stuff. And when you want to build something very good, you need to know what's happened behind, and you need to iterate like you can. And yeah, so this one is the advantage of the predictive is like you can put a lot of data in real time, so you can see what happened, and you don't need sometimes a lot of data. But for the application like finance or healthcare, like I told, it's just better to use machine learning models. Is why a lot of company now there's less finance AI agent, and it's something. I think in the next years, companies are gonna build agents in finance. It will be something good because now GenAI model cannot help you to build a good AI agent who is very safe, who is very reliable. So to do that, you need predictive models to do it. But predictive model is not enough. I cannot come here and ask my machine learning model. How are you? If you say, how are you? He will just see you, So when you take this GenAI model with predictive model and you make them collaborate together, so you just have what we call the mixture of AI. So how we do that? The technology, for example, we create in Humiris, and you can do it yourself, is we create a model who can orchestrate different models together. You say, okay, that's good, but I can just prompt a model and do that, but no. You need, for example, in your specific domain, if you are health tech, for example, in health tech, you need to split your task. You go to say, okay, I want to take, I don't know, my twin brother is cardiovascular surgery, like it's something very hard. He cannot use ChatGPT to give advice to the patient. He needs something very accurate. So what he can do, he say like, okay, this one is my job. How I do my job? I do step 1, step 2, step 3. And so you will benchmark all the steps you need to do your job. And now you will say like, okay, to do this step, I can take different type of model to do each type of steps. And that. So you need to create this data first, the data set to know the task of the task of each model, like the orchestration stuff, and the second to know which model is good in which tasks. Like the person just behind me, before me, talk about to choose the right model to do the good task is something very important. And we at Humiris, we did it before, so people don't have to, to make the benchmark every time there is a new model. But in our system, that okay, this model can do this type of task, this type of processing, and yeah. So it's really be how it's working. I think I'm on the time. So just to talk about Mr. Expert, because Mr. I come from Mr. Expert. Mr. Expert, the difference is when you want to build one model from pre-trained, you do Mr. Expert. Like, so we have DeepSeek, who has amazing model, and it come from this type of architecture. And after we have Mr. Agent, there are a lot of people who talk about who work on that, and something I talked before. The big problem with the Mr. Agent is this Mr. is not so smart, because you need to prompt them before. You need to tell to this model you need to do that, this model you need to do that. Is not so smart. So if I ask a question, for example, I say, okay, this model, take the question, after I give to this model, after I go to find this answer in database, so it's a chain of answer. That's good, but if I want just an answer who don't need to do all these chains, it's lots of time and lots of tokens. So it's good your model decides autonomously how to manage this orchestration. And it is what we resolve with Mr. AI, and it is what you could do yourself. So before build multi-agent, it's good first to build this brain who is powerful, because when you build the powerful brain, it is easier for you to duplicate to create a smart AI agent. Because some people just want to create agents with one model. That's good, but in real time, human doesn't work like that. Now I'm talking to you, I'm thinking, I'm acting, so I'm doing different requests at the same time. So if you want to build something very reliable, something very accurate in long term, it's good to take this concept. And yeah, I think it's a little bit finished. So if you want to use our Daddy1 model, you can just scan the QR code here, and you can have access to our model. Just to show you, I don't know if I have time, but
you're good.
Yeah,
you're good.
Okay. And today I'm happy to announce we're gonna launch our model Daddy1, who I say supports Claude 7, so you can have access directly in your editor in Cursor and continue a client. It's very easy how to do that. You just come to, for example, VS Code. Yeah, so I was running something, but I think I don't have time to make a good demo. But it's easier. Here we are in the client. Is OpenAI compatible? You just need to put the endpoint of our model, just the API keys, and you have directly access to our model. In the same thing for continue, you just need to add the model easily here. If you don't want to use our model, you can use your own. You can create your own models. Like something I say here is very easier. You create the own model. You make OpenAI compatible, and you can use it in any type of platform. We will do it very fastly. And every time there's a new update of model, we create our mixed model and we deploy it without a lot of million, but with a good scale. And yeah. So thank you.
Thanks, Joël. Just a quick question to start. How do you select a model for a specific task, and how do you orchestrate the other models?
Yeah, good question. So how to select what we did, we train We train our model on 200K datasets, but especially on a dataset who you need reasoning spec, like coding, health tech, and fintech. So the model could, first what you say, like we give him the question, and we take different models to answer, and we make them collaborate. And after we make reinforcement learning. So for the coding, we hire just high technical people to say like, okay, to answer this question, you need to do step 1, step 2, step 3. So it's why like the reinforcement learning we make at the end make the model better. So it's like a school, you go to, I don't know, I was in Stanford, you go to Stanford, you put any type of student as the arts of the school, but you have maybe a best student with some good skills. So it is what we did. So we create this data set first, this infrastructure. So every time you put a new model, we make reinforcement learning in the post-training. So it's not something we make in pre-training, like on O1, the chain of thought, like you could see. I will just show something very fast. I don't know if I have it. Oh. Yeah, I didn't have time to go to. Oh. Wait. Okay, I think I will make it. So here, for example, I will choose how is look our platform. You come here, you choose any type of model you want to mix. If your own fine-tuned model, you come and you mix them. It's very easy after you save it. So it's parallelized. So you take the question, and on inference, when you ask a question, he will do the whole task for you on inference. So every time you want to update the model, you can do it. And like what I said, when you take just normal reasoning model, they think a lot after give you the answer. What we did is like we execute in different overview and different parallelist tasks, and after we make the aggregation to give you the answer. Is why we have a better result than just normal foundation model.
Cool, thank you. Do we have questions for Joël? No questions? Yes, here.
No, I was kind of wondering about the use cases that this would be advantageous for, and you're saying accuracy, and maybe it's in industrial settings, right, where accuracy maybe has to be greater. But one thing that I think is important maybe is the cost and performance related to this, right? If you're hitting many LLMs, I'm assuming there's an inherent cost going to all of those, and then your speed will be of the slowest LLM, and then you still got to aggregate and figure out the cohesive answer. So are you targeting specific verticals, as you were mentioning earlier, like healthcare, where maybe the trade-off of cost and speed is worth it for the higher accuracy and reliability? I'm just trying to sense who's it for, like who's your target audience that would really appreciate what you're building?
Exactly. Good question. So like I said, for customer support, for example, you need fast answer, and not, sometimes you need reliable answer, but fast answer is good. But in healthcare, people, or in fintech, people prioritize a good quality answer. So this type of domain, like health tech, you cannot just give to people wrong answer. It's not possible. Like, because of that, they will never use LLM. But if you give them every time good answer, so they will use it. So our system is more for fintech, health tech, and coding, especially in coding. So for example, you say, it costs a lot because there's lots of models working together. That's good. For example, if you take, if I want to take the cost of model here, Llama is cheap, it's not so expensive. And if you take a lot of open source, you can build powerful model with just open source, so something's good too. But it takes time. But when you compare it to Claude in Cursor, for example, what our developer love is like, you need to prompt Claude 4 times before have the answer with our model in 1 time. So imagine you need to be here, just prompt and see, oh, it's not good, I need to prompt it again. So it takes you a lot of time, to come back and do it. But you ask the question with our model 1 time, and he do it for you. So it's depend every time. If you say, okay, make just a correction of small stuff, maybe you don't need it. But if you want to build something very accurate and you need to deep answer, you need to deep very higher, you need more this type of model. So yeah, thank you.
Thank you. More questions? Okay, thank you, Joël.
Thank you.
Let's give Joël a round of applause.
Je peux l'enlever? Yeah.
Okay, next presenter will be Anthony.
One second. Where did it go? Oh, it might be over here. Not yet. Hold on. I can't find my mouse. Do you know why I can't see my other screen? Is it here, maybe?
Yeah, but I need to switch first.
Oh, okay. Okay. Yeah. I think we're good then.
Okay.
Yeah.
Good?
Yep. Cool. Let's see if everything here is good to go. All right. How's it going, everyone? Now, I am going to show you today how you can build AI-powered conversations with Twilio. All right. So before we start, hey, everyone, my name is Anthony. I'm a developer evangelist at Twilio. And if you'd like to reach out to me, I've got a QR code here which has some of the upcoming events that we're doing. If you want, you can give me feedback on this presentation. You can also look at the slides. I haven't uploaded them yet, but I'll do that after this presentation. So feel free to visit the QR code or the URL over there. All right, so in terms of conversational bots, first thing I want to do is I want to talk about the differences at a high level between a chatbot and an AI agent. So who out here has used a chatbot? I'm sure most of us have. Raise your hand if you have. Yeah. I know it's most of y'all. So essentially, chatbots are basically, they're old school, right? They're very rule-based. They follow simple conditions, right? Let's say you have a bot, you push 1, it does this, it does that. If you push 2, and so on and so forth. And basically, all of those answers are predefined. It's not very smart. Now, AI agents, on the other hand, are context-aware. They can respond naturally and add a little bit of a personal touch to the messages and whatnot. And they can also learn from conversations in the past. I'd like to introduce to you a product at Twilio called AI Assistance, which is it's a framework that allows you to build these customer-aware agents. So basically, you can build your own AI bot. if you were to do this yourself using some code, it's kind of difficult because you have to train your models, you have to manage infrastructure, you have to integrate with services and all that kind of stuff, and it's quite difficult. Now, if you don't have a lot of AI expertise, you might want to use AI assistants because it's quite easy to do. There's not a lot of code involved. You can just use a interface, which I'll show you later. It's perfect for people like me. I'm actually not an AI developer. I'm not really in the AI space. I am a developer, but this tool, it was perfect for me because I could build an application in like 5 minutes, and it works really well. So here are a couple of reasons why we like to promote AI assistants and why we think it's great. So the first one is customer memory. So what that means is your assistant can be customer aware. So let's say you have an existing conversation with a customer. Maybe you already know their name. You might know what product they have saved in their shopping cart if they're on a store website. So using customer memory, we're able to extract that data and throw it into the conversation so the agent knows that they're talking to someone, so it gives it a lot of personalization. Now, for knowledge and RAG, a lot of people are building RAG right now, and AI assistants uses RAG. So you can upload your own files, you can crawl websites, you can connect to vector databases and things like that. Third reason are API tools. You're able to integrate with REST APIs. You can get or post data, and you can also integrate with webhooks, which is great. And then fourth and finally, this is a Twilio product. And if you're familiar with Twilio, you might know us for SMS, email, WhatsApp, phone call, so on and so forth. So the great thing about this is it's omni-channel. So you can create your assistant and then easily connect it with whatever channel you want. So for example, maybe you want to create an assistant over text. You could do that really quickly, or you could transfer it to voice. So you could literally create a bot over the phone really quickly. So yeah, that's my intro of AI assistants. I'm going to do a little demo here, and hopefully the demo gods are in my favor today. I'm gonna pray to them really quick. But yeah, here is our Twilio console, and let me zoom in a little bit here, just so that those of you in the back can see everything. But this is our Twilio console. It's our homepage. And what I have here on the left are various Twilio products. And you can see I've already pinned one here called AI Assistants, which is what we're talking about today. So I'm going to click on that, and I'm going to go to My Assistants. And here you can see I've created one previously called Demo, and I might reference that a couple of times just to make sure I have everything done correctly. But I'm going to create a new assistant, and I'm going to call it Live Demo, because that's exactly what I'm doing right now. And I'm going to create this assistant. And this is the user interface, right? It's very friendly and quite easy to use. The first thing that I will note here is, we've got our properties, which we can configure. If you want to, you could enter in your business goal. You can pick your AI constellation, and you can enter in your personality prompt. So by default, it tells you that you're a helpful assistant. And I want to change that. I have some text here that I am going to copy and paste. And we're going to change up the personality of our assistant. We're going to say, hey, you're speaking to a live audience right now at an AI developer meetup. You'll give direct answers without any fluff. Keep it professional and friendly. And when we're sending URLs, do not convert them into Markdown. That's a little hack there, but you'll see what that does later on. But I just enter in a prompt, and I click the Save button. And it's that easy to build an assistant. So up here, you can see a simulator button, which you can use as your simulator. So here, I'm going to click the plus sign, and I'm going to create an identity. I'm going to create a Twilio identity here. You can name it whatever you want. You could enter in a phone number, an email address, whatever you want. And here, I can literally test my agent in real time. So the first question I'm going to ask it is, hi, what's up? And hit the send button. Let's see what it says. Hello, I'm here at an AI developer meetup, ready to answer any questions you might have. right? And obviously it knows that because of the prompt that I gave it earlier. So next up, I'm going to ask it this question right here, which it should not know, right? Because how could it know? I'm going to ask it, what is the AI user group in SF? And let's see what happens. It says, I don't really have any information about this AI group in SF. However, usually AI groups do blah, 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 so on and so forth, right? So it doesn't have any context on what this meetup is. And it shouldn't, right? Because the models behind the scenes are generally outdated. I think GPT-4 is like updated as of like May 2024 or something like that. So it really has no context of this group. Next, I want to ask it another question. I am going to ask it just a random question with no context. I'm going to be like, when is Signal and how much do tickets cost? So that really might not make sense to you, but and it doesn't make sense to the agent either, right? It doesn't know what the dates are or the prices are for Signal, but it does know that Signal is Twilio's developer conference. And for accurate and up-to-date information, basically, you should visit this website. So again, it doesn't have any context on Signal, it doesn't have any context on how much tickets cost, and it has no idea what this user group is. And that is totally normal behavior. But let's change this, and I'll show you how simple it is to give it a little bit of context and life. So I'm gonna go back into the live demo here, and we are going to go to this knowledge tab. If you recall earlier, I was talking about knowledge in RAG. So essentially, I'm going to add a new source right here, and I have a name here, which I'm going to give it. We're going to call it, I'm copying and pasting here, AI user group, and we're going to give it a description. And I'm just going to say that these are the details of our this user group. And I am going to copy and paste a website here. So I'm giving it context via a website URL. And I am going to increase the page depth to 1. I don't know why I'm getting invalid URL. Let's try that one more time. Paste that there. Okay, great. So what I'm doing is I've created a name, a description, pasted in a URL, and given it a page depth of 1. So let me show you what this website actually is. It is the AI user group's website, right? So I've pasted in this website, which has information about the group, but I want you to notice something. There's not a whole lot of information about the group, to be honest. It just really shows you like what events are happening. But you'll notice that like there are some links here. For example, there's a link to LinkedIn. If I were to click that, you know, there are details about the user group inside of this page. So right here, wherever I am putting a page depth of 1, I'm actually going into those first level URLs and I'm looking at the data there. So yeah, I just wanted to make note of that. You can also change it to update. In this case, I'm just setting it to never, and I'm going to save this source right there. All right, next up, I want to add another knowledge source. So I'll click this button, and this time we're going to upload a file. Now, I didn't mention this earlier, but there are a few things you could do here. You could upload, not upload, but you could add a website, you could add raw text, you could upload a file, and you can connect to a Pinecone vector database if you want. In this case, I'm going to upload a file, which I have right here. I have pre-populated just a random PDF with some information, and I'm uploading that there. And then I am just going to copy and paste the name and the description again. So this is signal information in a PDF. And the description is that, okay, this is basically a PDF. Not the greatest description in the world, but it is accurate. And then I'm going to save this new source. Now, this might take a couple of seconds. We'll wait here maybe a minute or two. It does take a little while to upload a PDF, especially considering the file size of that PDF. But just to recap, what I've done is, right, I'm using AI assistants. I showed you earlier that it has 0 context about our meetup. It has 0 context of Signal. It doesn't know how much tickets cost or anything like that. And what I've done right now is I've added 2 knowledge sources. I'm connecting to a external publicly available website, and you can connect to any website you want. You could go to, whatever, Amazon or whatever you want. And then I've uploaded a PDF. You can see that it's still in progress, and I'm just trying to talk right now to see if it completes. Oh yeah, there we go, it completed. So now what we're gonna do is we're gonna go back and do our simulator, and we're gonna ask it similar questions. This time I'm going to ask it, let's scroll down here. What is the AI user group in SF, and who are the speakers for the developer meetup? So let's see if our assistant knows that information. And here in the simulator, you can see some basically logs. You can see that it's using our knowledge source and so on and so forth. And look at that. Look at that. I think it got it correct. So it says the AI user group in San Francisco is a community that organizes events that are focused on AI. For the event number 24, right, the speakers are Allison and Hector, which is not 100% accurate, so you're gonna have to fine tune it yourself. Yeah, okay, yeah, they're speaking after, so it's all right. And it does tell us that the event is scheduled today from 7 to 10 at 972 Mission Street. So, boom, it was that easy to give it some contextual data. Now let's ask it more about Signal. So I'm gonna go here and I'm gonna be like, okay, when is Signal and how much do tickets cost, right? If you remember, I uploaded that PDF. It actually has that information. So we're basically scraping that PDF. And look at that. It says Signal is gonna take place on May 14th and 15th at the Marriott here in SF. And current ticket price is $900. And that is the standard rate. But that, that's kind of expensive. That's pretty pricey. I should talk about what Signal is, right? I didn't ask it what Signal is, so let's ask it that. What is Signal? Let's see what it says. We know that tickets are $900, but like, what is it? What am I spending $900 on? Let's see. So Signal is our annual developer conference, and it brings together developers, business leaders from all these companies. And the thing it doesn't know is that this year, Signal, it's going to be our first time in SF since 2019, so we're bringing Signal back. It's going to be a really big event. Now, if you don't want to pay the full $900 for tickets, you're in luck. But let me ask my assistant, how can I get a discount to Signal? I want a discount. I don't want to spend $900 on a conference. So it's going to go through the knowledge base, and it's going to be like, oh, well, the standard ticket is $900. And there is an early bird discount for $700, but like, I don't know, that seems pretty pricey to me. I don't really want to pay $700 either. So let's kind of show you what else you could do with the tool itself. So we're going to go back into our demo, and earlier I showed you the knowledge tab. Now we're going to go into the tools tab where you can connect with APIs. So I'm going to add a tool. We're going to give it a name called discount code, and we're going to give it a description. Basically, it's just going to return a URL. It's a very simple app. And I'm going to paste in the webhook URL of my application that is running on this endpoint. And we're going to make a GET request. You could change the schema here if you want, but I don't. My thing is really basic, so I'm just going to hit Create Tool, and we are connected. So you might be wondering what this URL is actually doing. So this is a function, a serverless function that I created earlier. I'm just going to show you what it is over here. So Twilio also has a serverless environment where you can create applications in the cloud. So here I've created a function called /demo, and it's just a really, really like, it doesn't do anything. It just returns a URL, which is the URL that we're looking for. So very basic stuff here, but obviously your endpoint or whatever endpoint you're using could be completely different. This is just a demo, so it's very simple. But let's go back into our live demo, and we're gonna go here, and yeah, we're already connected. So now I can go back into the simulator, and I can ask it, can I get a discount? Can I get a discount? And again, it knows what I'm talking about, right? It has context that we're talking about, signal and whatnot. And now you could see here that we are using the discount code which I created earlier, and boom, it hits our endpoint, and we get this response. You can use the following link to access a discount for Signal, and this is the URL right there. By the way, if you're wondering how much the discount is, tickets, remember I said they were $900, then early bird $700. Right now we're offering discounted tickets at $140, 85% off. If you're interested, feel free to go there. But we're not done with this demo, right? I'm gonna show you the power of all of this with Twilio and our APIs. So remember, you can connect this to channels. So what I mean by that is if I go up here, back into our demo, there's a tab here called Channels, and this allows me, right now I'm doing all of this in the simulator, right? I'm just testing it, but I actually want to deploy this to production using a channel that I want to use it in. So if I wanted to, I could click on this button right here, which I did earlier. It's going to bring me to this samples web page. And I'm not going to do it right now because I did it earlier, but basically I literally just click like one button right here, deploy this application. It's going to create a application for us, and it's going to give us an ID. All I do is I copy this ID, and I go back into our console. I go into my phone numbers tab. I click manage, and I look at the phone numbers that I own. One of the phone number that I'm using for this demo is this one right here, which is blurred out. And then basically I just paste that URL right there. So whenever a message, whenever somebody texts my phone number, we're going to hit this webhook, and boom, you can interact with the application. So I want you to try it out, actually. Let's go back into the slides, and hopefully it'll work for you. I would love for you to try out the demo. Scan the QR code. You can ask it various questions, play around with it. Again, this is all through SMS. And be sure, don't forget to ask it for the discount code if you want that URL for the discount, for the 85% discount, okay? That's really important. Okay. If it works for y'all, raise your hand, let me know that it works. Okay, sweet, looks like it's working. So yeah, AI assistance is super, super, super cool. I'll leave it up here for a couple seconds because I see some people are scanning the QR codes still. I'll give you 5 seconds. 4, 3, 2, 1. Okay, all right, so now, usually this happens at the beginning of a slide, but what is a Twilio, right? You might still be confused if I don't know if you are. Maybe some of you already know Twilio, maybe some of you don't. But Twilio is a customer engagement platform, and hopefully that demo kind of made sense for you. But essentially what we provide are APIs to developers that allow you to create personalized interactions with your customers or with whoever you want to connect with. So for example, you could use our messaging API, and you could just, a couple of lines of code, you could send out messages at scale to your customers or whoever you want to send them to. That could be any type of message you want. Let's say, for example, you get an order on DoorDash, right? They take a picture of the order. They're using Twilio right there. Let's say you call your Uber driver. They're actually using Twilio to make that phone call. It's not actually the Uber driver's phone number. So hopefully that clears things up about Twilio itself. And AI Assistance is our AI product, okay? Now, friendly reminder, right? Wink, wink. Signal is our 2-day developer conference that is happening in person here in San Francisco on May 14th and 15th. Again, this is the first time we've been back since 2019. The last couple of years, we've done it in London, Singapore, Sao Paulo, and we're so excited to do it again in San Francisco. Again, regular tickets are $900, but today you can get 85% off. Now, you'll see 2 QR codes here. The QR code on the left is for people who want to spend a lot of money. It's a direct discount for 25% off, but no, you don't want to do that. You want to scan this one on the right, which is going to take you to the demo that I just showed you, and then again, ask it for the discount code. You'll get 85% off, okay? We only have 40. We can only give you 40, so be sure to ask for it. Now, if that is still too much money for you, I've got a surprise. I haven't told that many people about it yet, but follow us on social media, maybe Twitter, maybe LinkedIn, who knows. What we're gonna do next week is we're gonna post on our social media, because myself and Andrew over there in the red jacket, we're gonna be going around San Francisco hiding Twilio phone numbers and QR codes around the city. If you're the first person to find them on each, I think we're giving around 5 or 6 codes. So the first 5 or 6 people-ish who scan the code are gonna get a free ticket, okay? So we're gonna post the locations on our social media, so follow us there to get your free tickets, okay? Awesome, awesome, awesome. So so initially, I was supposed to talk up here for like 10 or 15 minutes, and I'm like kind of talking slow, and then they changed it to 30 minutes. So I'm gonna fill some time here with a little bit of magic, okay? It's gonna be a little different. And this is a sneak preview of the talk that I'm actually giving at Signal. I'm gonna be doing a magic show at Signal using some AI in Twilio. So this may end miserably, okay? I've never done it in front of an audience this big. Usually I just do it in front of a few people. So a lot of pressure here, but I have a deck of cards here, okay? And I need a volunteer to help me with this trick. Raise your hand. Don't all raise your hand at once. Okay, this gentleman up here. Give him a round of applause, guys. All right, how's it going? What's your name? What's that? Naveen? Yeah. Nice to meet you, Naveen. Do you mind standing over here? If that's all right? Okay. So we only have one microphone, so it's okay, but thank you so much for volunteering. Okay, I'll grab that, yeah. Okay, so I've got a deck of cards here, and I'm gonna remove the jokers. Let's see. We're gonna remove the jokers, and I want you to shuffle these cards. Yeah, it's okay. I'm bad at shuffling too. I'm really bad. So he's shuffling the cards here, and whenever you're done, just hand them back to me. All right. You're done, right? Feel comfortable with that? Okay. So I am going to fan out these cards over here, okay? And I want you to pick a card, any card, but don't look at it, okay? I don't want you to look at it. Are you sure you want that one? You positive? Okay. So he picked a card. He doesn't know what it is. I don't know what it is. No one knows what it is. So I'm gonna put the rest of the cards. I don't have a whole lot of space here, but I'm gonna set them down right here, and I'm dropping things. But I would like you to put the card face down here and make sure I don't see it. Okay? Okay. So do you? Okay. All right. Okay. Do you agree that no one knows what the card is? I hope so. Okay. So I'm not a magician. I have no freaking idea what the card is, but I have a phone here, and my phone can do a lot of magical things. So what I'm gonna do is I'm going to open up my text message app. Unfortunately, I can't share my screen because the app isn't working, but actually, Andrew, you gave me a tip. I'm gonna open up Photo Booth and I'm gonna try this. Never done it before. Oh, yeah. Oh, this is gonna be tough. Okay, so we're gonna do this, and I've got my phone here, and you guys might be able to see this. It's a chat with David Blaine, okay? I'm friends with David Blaine. Do you guys know David Blaine? Yeah? Okay, so David Blaine is a really famous magician. He's one of the most famous magicians in the world, and I actually got an opportunity to meet him. We're pretty good friends. So I'm gonna ask David if he could guess your card. I have no idea where he is, but I'm going to ask him if he can try and guess your card from wherever he is. So I'm going to type in a message here. I'm going to be like, "Hi, David. What should I ask him? I should be like, "Hi, Dave. What was your name again? Sorry, Naveen. Okay, I'm here with Naveen. How do you spell it?
That's fine.
Yeah, okay, sorry. Okay, hi David, I'm here with Naveen and he picked a card. Can you guess what it is? Okay, so I'm gonna show this to the audience. So I'm literally talking to Dave. I'm like, "Hey Dave, I'm here with Naveen, and I'm asking him if he knows what the card is." I think it's reversed. It's mirrored, which kind of sucks, but I want you to verify that that's what I'm sending. Yeah, okay, looks good. All right, let's send it to him, and let's see if he answers. He might be busy, you know, he's David freaking Blaine, so like, who knows what he's doing right now. But, hey, look, he said, let's try and check our backward reading skills. It says, "Hey, Anthony, busy here, but Naveen's card is the 3 of diamonds." All right? So, Naveen, I want you to flip over that card and see what it is. Show it to everyone. It's the 3 of diamonds, guys. No freaking way. Thanks, David. Thank you. Okay. Yeah, so that was, thank you so much, Naveen. Yeah, thanks. Okay, so yeah, that was like completely unrelated to AI assistants, but I had to show it to y'all. If you want to see more, go to Signal. Remember the thing I showed you earlier, okay? It's going to be sick. I've got a ton of tricks, and we're going to do a bunch of fun stuff. So yeah, that does it for me. Again, I'm still sharing this. I should stop. Okay, again, my name's Anthony, developer evangelist at Twilio. Scan the QR code if you want to connect with me. And that's it. Thank you so much.
Wow. That was a show. Thanks, Anthony.
Yeah, thank you.
Questions?
So I have 2 questions. The first one is, do you guys support Discord?
Do we support Discord? Unfortunately, we do not support Discord. It's not one of our channels.
Is there like a way to work around?
I haven't played around with their API too much, so I'm not too familiar with it. Do you know, Andrew?
You could use functions to do stuff. Like you could technically so basically functions are just like, again, serverless functions. So if you can talk to the API, then
Yeah.
then hey, you could totally have some pieces of like people texting in through Twilio and talking.
Oh yeah, you're right. I actually have seen a couple of demos like that. So for those of you on the stream, Andrew was saying we have Twilio functions, which I kind of showed you earlier. But essentially, again, I'm not familiar with Discord's API, but basically you could text in on a phone and then like send it over to Discord or something. I think I have seen instances
So
of-
Discord, it's kind of like a Slack, but it's very popular with like developers.
Yeah. I know what it is. I just don't know how their API works. But I believe you could do some workarounds, but it's not natively supported. Like you can't. There's no API to actually send out a Discord message.
Gotcha.
Yeah. Oh.
Right.
Yeah, maybe. Yeah.
Yeah, I think that's what we're thinking. Yeah.
Cool.
So sorry. The second question is that I feel like you guys just equipped all the tech scammers with like super powerful assistant. Do you have any plans in the company to like make sure? Well, is there a way to like not have scammers use it?
Yeah. So all of this was done through a phone number. And that phone number is something that you purchase. I didn't show it to you earlier, but I purchased a phone number that's been pre-registered with a carrier. And whenever you buy a phone number, there is a whole regulation process. So you actually have to submit documents. You have to submit your brand and prove that you're an actual business. There are various use cases that you have to prove that you're sending certain messages and they can't be like gambling or illegal type of messages, and basically all of that has to go through a vetting process, and then after it gets approved, you're good to go with that phone number, and then you can use it for various channels. So those are our safeguards.
Just one thing I was wondering is like you talked about how you can create these assistants using the Twilio UI, but how is it different from like stuff like Flowwise AI or like Langflow? Because you could just connect to like a
Yeah.
Lambda function that connects to Twilio.
Yeah, so earlier I mentioned I'm not too familiar with the AI space, but my understanding is that whenever you're using Langflow, oh, you said Langflow or LangChain?
Langflow.
Okay, I haven't used Langflow that much, so I don't know exactly. I know it's kind of similar in the fact that it's like a drag and drop UI. That's a good question. I don't really know. Andrew, any thoughts?
Yeah, it's like the native integration with the
Right.
Twilio ecosystem.
Yeah,
If
yeah.
you're looking to be able to like
That's a good
send
answer.
emails through SendGrid, if you're looking to be able to send text messages, WhatsApp messages, it's so much easier. Like you can just set up and
Yeah, like,
I see, I got it.
so again, for people on the stream, Andrew, again, thank you for the help, but his thought was that like, okay, you can integrate with the channel of your choice very easily. I'm not sure how Langflow works whenever you're integrating with channels, so I can't really speak on that, but yeah, if you're planning on using it through a voice call or SMS, then it just makes sense to use it on the platform that you're already using, which hopefully is Twilio.
Sounds good. Yeah, that makes
Yeah.
sense.
So I wasn't expecting to have this question when I walked in today, but how did you get the bot to guess the card right?
What bot? What bot? That was David freaking Blaine, man. What are you talking about?
Does that work every time? Or was this like, did David Blaine just...
I don't know. You'll have to
Guess
go to
what?
Signal and find out, because I'll do some more tricks. Yeah.
Okay. All right.
Great selling point.
But yeah, a magician never reveals their secret.
No more questions? Here, yeah.
Hi, I'm Philippe.
Hey.
I'm building voice agents, so I'm kind of curious, and I have Twilio as a way to pick up the phone call. And so I'm curious that, I'm assuming you do voice
Yeah.
agents. I was curious what kind of voice technology you're using. Is it proprietary? Is it one of those out in the market you're connecting to? What are you using?
So there's a couple of things I could talk about here. So one of the things we just announced is a partnership with 11 Labs. So you could use some of their voices, which is really cool. That's one thing.
That's why I used that one. I was
Yeah,
okay.
yeah, it's really cool. Another thing we announced maybe a couple of months ago is a partnership with OpenAI and using their real-time API. So essentially you can have like a natural, so you could use that with 11 Labs. Boom, you have a natural conversation using GPT and 11 Labs. Yeah.
And are you also giving us a choice which LLM we're using? Can we bring our own LLM? Like, how does that work?
So I am not 100% clear on that, but my understanding is that essentially the model in the assistant that I showed is it essentially like picks and chooses which model performs best based on the task at hand. Again, I'm not an expert in the field, so I don't know exactly how it works, but that's generally how it works.
And maybe this is a technical question. One of you may know.
Yeah, Andrew might know.
Yeah, it's what's the responsiveness on the voice side? So typically there's a discussion in
Yeah.
the industry, you want to be like around
Latency.
700 milliseconds or less.
Yeah.
Are you able to go practically like real time, or is there like a wait because
That's a
it's
great
overhead?
question. I don't know in terms of milliseconds how quick it is. I don't have that number off the top of my head. It's relatively quick. I mean, I've tested it out myself and it was like quite natural. I'll try and look that up later and-
cool.
and let you know. Yeah.
Thanks.
Yeah.
Thank you. When it's going to be available?
Oh yeah, great question. So right now, if you want to use AI assistants, it's in beta. So just reach out to me and I can give you access. We're going to launch it. It's going to be generally available sometime soon. Can't announce that date quite yet, but just let me know if you want access to it.
Sounds good. And what about pricing?
Pricing. Okay, so each month you're given a certain amount of messages that you can send via AI assistants. I believe it's around 100 a month. And then depending on the channel you send it through, you're going to pay various fees based on that channel. And it's all usage based.
Cool. More questions? No? Okay. Thank you, Anthony.
Thank you.
Great presentation.
Thank you.
All right, and now it's your time to shine. If you have any announcement for the community, you can come here. Anyone working on something cool, anyone hiring, anyone looking for a job, you can come here and just present the opportunity to the community. Anyone working on something cool? Yeah, come here.
Working on something cool. Hi, everybody. My name's Alice. I'm here visiting from Austin. And one of the reasons why I'm here is actually putting on an event tomorrow for my favorite podcast, which is called My First Million. So if you guys are a fan of that podcast, I'm putting together a fan meetup tomorrow. Come talk to me afterwards.
Nice.
What is it about? The podcast? First of all, it's not my podcast. It's just the podcast that I absolutely love. It's a couple of tech guys. They talk about all sorts of cool projects. They interview a lot of entrepreneurs. And both of them were based out of San Francisco. I did invite the host, Sam Parr lives in Connecticut, Sean Puri, to come out. Not sure whether or not he's going to be able to make it tomorrow, but it's just a bunch of fans getting together, bonding over similar interests. Yeah.
You work on something cool. Aaron, anyone else? Cool. All right, next time. So pizzas are served. We can start networking now. Yeah? You wanted to present? Okay, it's not too late. You can come.
Hey everyone, I'm Akash, and I'm a data engineer. I have around 4 years of experience. So if any of you guys are working in a company and it has anything related to data, getting raw insights, building ETL pipelines, end-to-end support, I'm a good resource and I'm looking for a job right now, so you can reach out to me. Thank you.
Cool. Great. Anyone else? Okay, yes, come here.
Thank you. I'm a senior AI consultant at a Big Four firm, and I'm a data scientist, machine learning engineer, but also prepare roadmaps and I guess a vision for companies. So if anyone is looking to get any sort of consulting, happy to like be a rubber duck or help brainstorm ideas, put together something. Yeah, thank you.
Good. Yes.
So if any of you guys are trying to do property tax appeal this year, you can use my side project called Comp Finder. It's spelled COMPFINDER. It uses AI to help you file property taxes. Instead of paying lawyers hundreds of dollars, you pay $20 for this one. And oh yeah, I also was featured in SF Standard because of this really cool tool. Yeah.
Cool. $20, that's a steal. Anyone else? All right. So let's get to networking. It's going to be in the back, and pizzas are served. Thank you, and see you next time.